Mesothelioma is a type of cancer that forms in the mesothelium, which is a protective lining that covers many of the internal organs of the body. It is usually caused by exposure to asbestos. Malignant pleural mesothelioma, MPM, is the most common type, forming in the lining of the lungs. Unfortunately, mesothelioma is an aggressive cancer with poor prognosis. Currently available treatments for mesothelioma including surgery, radiation therapy and chemotherapy can extend survival, but are generally not curative for late-stage disease. Therefore, there is a great need to develop new targeted therapies for mesothelioma. MicroRNAs, mRNAs, show promise as therapeutic targets for several types of cancer, including mesothelioma. mRNAs are short, non-coding RNA molecules that function to negatively regulate gene expression at the post-transcriptional level. They bind to complementary sequences within messenger RNA, mRNA, transcripts to repress protein translation or induce degradation of mRNA. A single mRNA can target hundreds of different mRNAs, and alterations in mRNA expression levels have been shown to play an important role in cancer development and progression. Many human cancers, including mesothelioma, show distinct mRNA expression profiles compared to normal tissues. Several mRNAs have been identified as specifically dysregulated in mesothelioma and shown to influence key cancer pathways and processes like cell proliferation, apoptosis, metastasis and chemotherapy resistance. Therefore, targeting specific mRNAs that act as oncogenes or tumor suppressors offers a novel approach for mesothelioma treatment. One promising strategy involves restoring tumor suppressor mRNAs that are downregulated in mesothelioma using mRNA mimics. For example, miR34 is a well-characterized tumor suppressor that is epigenetically silenced in many cancer types including mesothelioma. It inhibits several oncogenes that promote cell cycle progression, stem cell renewal, epithelial to mesenchymal transition and resistance to apoptosis. In mesothelioma cell lines in most models, re-expression of miR34 using replacement therapy led to significant reduction in tumor growth, invasion and increased sensitivity to chemotherapy. Similarly, miR16 is downregulated in many solid tumors including mesothelioma and acts as a tumor suppressor by targeting several oncogenic pathways. Delivery of a miR16 mimic in mouse mesothelioma xenograft models inhibited tumor growth by inducing cell cycle arrest and apoptosis. Clinical trials are now underway testing the safety and efficacy of MRX34, a liposome-based miR34 mimic, for treating various cancers. Another approach is to inhibit the expression or function of specific oncomers that are upregulated in mesothelioma. For example, miR21 is one of the most consistently elevated oncogenic mRNAs across all cancer types examined so far, including mesothelioma. It promotes tumor cell proliferation, survival, invasion and drug resistance by repressing multiple tumor suppressor genes. Inhibiting miR21 function using antisense oligonucleotides or mRNA sponges reduced growth and induced apoptosis in mesothelioma cell lines in most xenograft models. miR183 is also frequently overexpressed in mesothelioma and promotes an aggressive phenotype by inhibiting tumor suppressors like programmed death ligand 1, PDL1, and metastasis suppressor 1, MTSS1. Delivery of anti-miR183 oligonucleotides reduced mesothelioma tumor growth and lung metastasis in mice by reversing the oncogenic effects of miR183 upregulation. Another interesting approach involves targeting networks or clusters of cooperative mRNAs rather than single mRNAs. For example, miR1792 cluster is an oncogenic mRNA polycis strand frequently amplified in solid tumors including mesothelioma. It activates tumor-promoting pathways like E2F, MEK, TGF-beta and signaling. Inhibition of the miR1792 cluster using antigomers reduced mesothelioma cell proliferation, migration and invasion in culture as well as tumor growth and dissemination in a mouse xenograft model. In addition, some mRNAs like miR200 family members act as metastases suppressors by regulating epithelial to mesenchymal transition, EMT, and cancer stem cell properties in mesothelioma. Upregulating miR200 with mimics inhibited mesothelioma cell migration, invasion and in vivo metastasis in mouse models. Combined targeting of oncomers and restoring tumor suppressor miRNAs holds promise as a synergistic multipronged miRNA-based therapeutic strategy for mesothelioma. Interestingly, some natural agents and dietary components can also modulate miRNA expression profiles in mesothelioma cells. For example, curcumin, a polyphenol derived from turmeric, downregulated the oncogenic miR21 and upregulated tumor-suppressive miR16 in mesothelioma cells, thereby suppressing tumor growth and sensitizing cells to chemotherapy both in vitro and in vivo. Green tea polyphenols and luteolin, a flavonoid found in many plants, suppressed mesothelioma tumorigenesis in mouse models at least partly through altering miRNA regulatory networks. These natural compounds hold promise as chemopreventive or adjuvant therapies for mesothelioma by epigenetically modifying miRNA expression. miRNAs show tremendous potential as novel therapeutic targets for the treatment of malignant pleural mesothelioma through modulating specific oncomers and tumor suppressor miRNAs that influence key pathways in mesothelioma initiation and progression. Both gain-of-function approaches using miRNA mimics toward tumor suppressors as well as loss-of-function strategies involving antigomers or antisense oligos to inhibit oncomers hold promise. Combinatorial targeting of cooperative miRNAs or clusters may provide even better therapeutic outcomes. Natural agents and dietary factors that can modulate miRNA networks also warrant further investigation. Although still in early research stages, miRNA-based therapies open up an exciting new avenue for developing improved treatment strategies against this currently incurable asbestos-induced cancer. Further preclinical and clinical validation of miRNA mimics and antagonists are still needed, but they show potential as novel targeted therapeutics either alone or in combination with existing standards of care.